All right, number 22, second problem assigned yesterday. Construction. Construction worker pulls a 5-meter plank up the side of a building under construction by means of a rope tied to the end of one end of the plank. Assume the opposite end of the plank follows a path perpendicular to the wall of the building, and the worker pulls the rope at a rate of 0.15 meters per second. How fast is the end of the plank sliding along the ground when it is 2.5 meters from the wall of the building? So they've given us this 2.5 meters is the distance down here. But here's some important things we have to think about when we're doing this. Number one, shape. This is a right triangle, okay? We've got the wall here perpendicular to the ground. These are assumptions we can make in this problem. The worker is pulling this side up. I'm going to label this side of the triangle, the vertical side, Y, the bottom side of the triangle, X, and I'm going to call this piece right here H, or hypotenuse. Okay, now this is the important thing for you to know. As this is pulled up the wall, this Y distance on our right triangle is going to change. This X distance on our right triangle is going to change. The hypotenuse of our right triangle, the board is not changing. The board is always going to be a constant 5 meters. So that's going to be important for us in this problem. The rate of change going upward, 0.15 meters per second. We're going to, we don't have to assume it. It actually tells us it's at a constant 1.5 meters. So pulling up at 0.15 meters per second. And they're asking us, how fast is this end of the plank sliding along the ground here? Since this is the x dimension, we're going to label that as dx dt. We're looking for dx dt. So let's hop over here to the Google Sheet I just set up, or the Google Doc I just set up, and let's start putting in our important information. First and foremost, we're dealing with a right triangle. Okay? And we're specifically talking about the sides of this right triangle. So do we know an equation that relates the sides of a right triangle? We do. Let's go ahead and put that equation in. We'll call it x squared plus y squared equals hypotenuse squared. I'm going to have to pause this for a minute. The fire alarm's going off again. And welcome back. So sides of a right triangle, we know x squared plus y squared equals h squared. Okay. Something else that's going to be very important for us is that our board is 5 meters long. Okay, and that is constant, and that is going to be important to us. Okay, what else do we know? We also know that, make our font size a little bigger here, to about 18. We also know, new equation, that our dy over dt, how quickly that this is being pulled up the wall, how fast this y dimension is changing, that's going to be equal to 0.15 meters per second, right? Any other given information that we know here? We do. We know that, or let's identify what we're being asked to find. We're being asked to find dx dt. How fast is the board sliding along the bottom? And they're asking us to find that when x equals 2.5 meters. So that's all the given information we have. In fact, it's all the given information we really need in this problem. So for us, let's go ahead and start by recognizing that we're going to have to take the derivative of this equation. So we're going to go ahead and make that statement. We're going to have to find the derivative, d over dt, a time derivative of our equation, x squared plus y squared equals. Now here's something important. The board, the hypotenuse, is not changing. It is constant. which means we could plug it in immediately. So we're going to just put in there 5 squared, which is 25. And that is our first step to this. Now, we'll take our derivative. The derivative of x squared, that's going to give us 2x, and the fraction, the rate of change, dx over dt. Plus, derivative of y squared is going to give us 2y dy over dt. And the derivative of 25 is 0. So we're going to take a look at this, okay? They gave us an x value of 2.5 meters to plug in here for x. Great. They gave us a dy dt to plug in here. Great. dx dt is what we're looking to find. Here it is. The only problem left over for us is the fact that we don't have a y value to plug in. But we do have an x and a hypotenuse. And since we know it's a right triangle, we can go ahead and use our Pythagorean theorem, which is going to say 2.5, our x value squared, plus y squared have to equal 5 squared, or 25. We'll just put it as 5 squared for right. So if you go ahead and you do that math, and I'm going to have to hop on my calculator here really quick to do this. Give me a second to find my calculator on my phone. So we have to do 25 minus, wish I had a real calculator with me, 2.5 squared and then we have to go ahead and do the square root of that. We should get it, I believe, 4.33. And we'll double check that. Yep, about that. So we're going to say that our y value should get that y equals 4.33. I really wish I had done that as a new equation, so it looks nicer. Y equals 4.33. So now it's just a matter of plugging in all this information. That'd be 4.33. We should note that that's meters. Okay, I'm not going to go through doing all the decimals and multiplications, but you're just going to have to go ahead and plug in. You have 2 times 2.5 meters times dx dt plus 2 times 4.33 meters times dy dt, which is 0.15 meters per second. And that's equal to 0. And now that you're at this point, I'm going to assume you can do your multiplication, subtract this one over the other side, and divide by this constant here, which is 5. So go ahead and finish that up. I don't know what the answer is off the top of my head, but I'll add it to this in a little bit. I want to make sure I have enough time to make the third video. So go ahead and finish that one up and look for the third video in just a moment.